All right, guys, today we're going to talk about 7.2, the line of best fit. So up at the top here, I have a quick description of what we're talking about when we mean the line of best fit. So when I'm saying that, I'm talking about a line through data that can be used to make predictions. You can actually calculate a line of best fit. There is an exact line of best fit for every single data set. We are going to estimate, and I'll tell you as we're going through here the best way to estimate the line of best fit. All right. The whole purpose of a line of best fit is that if you were just given a table like this, flower sales in each year and the sale in thousands, we collect data, we look at data so we can make predictions, so we can learn something. I can't just look at this table as it is and make a good guess of how much money I am going to make or they are going to make in 2013 or 14 or 2020. It's going to be hard to just guess with evidence. And so what we do is we plot the data like I did here, and we find the line of best fit and use that line of best fit in the equation of the line to make predictions. So that's what we're going to do in this first example here. So I already went ahead and I graphed it on the scatter plot. And you can see that this looks like it has a strong positive correlation. It looks like we probably could find a straight line that fits most of those points or goes through. And what B says is it says write the equation for the line of best fit for this data. Let X represent the years since 2007 and Y represent the sale in thousands. So one thing I want to point out here is this part. Oops. It says let X represent the years since 2007. So in our table, that's just the years. If we switch this to years since 2007, that's going to be 0. That's going to be 1 year since 2007, 2, 3, 4, 5. And so on, okay? So those are the points that we're going to use when we're doing this. When you're picking your points, like I said, there actually is a way to calculate. We're just going to estimate. Your goal is that your line goes through the middle of the data. So that means if it can't exactly go through every point, when you draw it, you're going to have about the same above and below this line. So I'm going to pick the very first point and this fourth point here. That's not a great straight line, but it's gonna go, and we've got like 2 above it and 2 below. It's looking like it's gonna go through the middle. So I'm gonna pick again that very first point and the fourth point over here. I guess fifth point. 1, 2, 3. Yeah, fifth point. Okay, 4 years since 2007. So those are the 2 points I'm gonna pick to draw my line of best fit. So I came down here, I've already got these here. These are the 2 points I picked, 0, 305, and 4, 395. And we need to write the equation of a line. You guys know how to do that. The first thing we do is find the slope. Slope is change in y, y2 minus y1 over x2 minus x1. It's going to give me 90 over 4, which is 22.5. And then I need my y-intercept, which fortunately I have that. It's going to be my 305. So the equation of the line is y equals 22.5x plus 305. Okay, that's going to be the equation of the line. Now, again, this is the line of best fit because not every point in this data set is exactly going to fit that equation. Okay, if I plug in 1 for x, I don't get 330. So it's not exactly fitting every single data point, but it's a good model. And so part C says, according to your equation, in what year will the sales reach about 500 in thousands? Use mathematics to explain how you determined your answer. Okay, so graphically what we're looking at is something that isn't on our graph because the way I scaled it, we don't get up to 500. But look at this here. Remember that on a graph, these are your X, these are your Ys. So if it's asking for when the sales reach about 500 in thousands, that's saying when Y is 500, what is X? Or after how many years? Because X is the years. Okay, so we're going to use our equation to help us solve this. Switch colors here. So what I need to do is I need to plug in 500 for y and solve for x. So I've got 22.5x plus 305. Okay, so this is why a line of best fit is useful, because even though I know every single data point from this table doesn't fit along that line, it goes right through the center of the data. It's a pretty good representation of our data, so we can make predictions like this. All right, so the first thing I would do is subtract 30 from both sides. Then divide by 22.5. Let me pull my calculator up here. Believe it or not, I don't know what that is off the top of my head. Okay, and it's going to be 20 point, it looks like 8 repeating, so I'm going to round that to 89 equals x. So then we figure out, okay, what does this mean? So according to our equation, in what year will sales reach about 500 and thousands? So it will be exactly at 20.89 years that you will get to 500, okay? So remember, in our equation, the x is years since 2007. So we're going to add 20.89, or I'm going to round that up to 21 years. But remember, that is after 2007. So if you add 21 to 2007, the year this is going to happen is going to be 2028. Okay? Or really during 2027, but we'll round up to that 2028. Okay, so again, this is why line of best fit is helpful, because we can use that equation to make predictions about things that we don't actually have the data yet for. We're going to look at this next one. It happens to be number 23. If you can't tell, I kind of cut and paste from an old worksheet that we had. It says the table below represents the number of powerboats registered in the given year. Okay, this one gives us the equation for the line of best fit. It's y equals 27x plus 751, where x is the year since 1996 and y is the total powerboat registrations. Okay, so remember, if we're changing this to years since, that's going to be like 0, 1, 2, 3, 4, 5, 6, and so on. Okay, using the given equation for the line of best fit, which is a good prediction for number of powerboat registrations in 2015. So first, we're going to convert it to years since 1996, because that's what x is in this equation. So to use this equation, we need the variables to match up. Okay, so 2015 will be 19 years since 1996, right? So we plug in 19 for x. So we've got y equals 27 times 19 plus 751. 27 times 19 is 513. I'm going to go this way because I'm running out of room. So it's going to be 12,064. Oops. Cool feature, not something I need right now. Okay. So again, think back. What was it asking us? It was asking us, what is a good prediction for the number of powerboat registrations? Oops, that's not a price. That's supposed to be number of powerboat registrations. Okay, so in 2015, there will be 1,264 powerboat registrations. So again, we are using data that we've collected, finding a general pattern, that's the line of best fit, okay, a linear pattern, and then we're using that equation to help us make a prediction. All right. I'm going to go through number 1 here because I want to show you how I want you to do these without working too hard. So Chang wants to know if he is improving his skill on the cello. He created a scatter plot and drew a line of best fit. So all of that is already done for us. It's graphed, he drew a line of best fit, and he's showing us the 2 points that he drew the line through, okay? If he uses the points 2, 8, and 5, 1.5 from his line, which equation would best represent the line of best fit? So before you actually start calculating the slope, I want you to think about this in terms of what you know about a line so you can use the process of elimination on these 4 answers. The first thing that we can see here is that the slope of this line is negative. Okay, the slope of the line is negative, so we can eliminate B. Okay, the slope of the line is negative, so eliminate B. Next, okay, we can see that the y-intercept is going to be something above 10. It's going to be somewhere up here above 10. So the y-intercept is above 10, which means it can't be C and it can't be D, meaning your answer has to be A. Okay, so again, before you actually go through and try and find the equation of the line, you can use what you know about equations, about y-intercepts, about slopes, to use the process of elimination. Then it says write a sentence of a conclusion based on the graph. Okay, this is talking about the number of mistakes played and the time practicing. Okay, so it wants it in context. And what I would write here is the more that you practice, the less mistakes are made. You could even get more specific and look at that slope, and that means for every hour of practice, Chang makes 2 less mistakes. Right? Because that's what a slope is. For every 1 to the right, we're going down 2. So for every 1 hour practiced, we go down 2 mistakes. All right, I'm going to leave the other ones for you to look at because I think now that we have all of this information, you guys should be able to practice them. If you're having any questions, make sure you're coming to office hours or sending your teacher a message.